Hello everyone, this is Sabita Sunkara. Welcome back to our Enterprise Data Engineer interview series. Today's interview question: what is Delta Lake architecture? How does it solve the limitation of a traditional data lake? This is one of the most frequently asked interview questions for Databricks, Azure Data Engineering, Spark, and senior data engineering roles. So many candidates know the term Delta Lake, but interviewers expect much more than a definition. So they want to know why Delta Lakes was introduced, what problems it solves, and how it's implemented in production. So let's understand Delta Lake using a real enterprise scenario. Imagine you are working for a global e-commerce company. So every second million of records are generated from online orders, payments, customer clicks, product catalogs, logistics systems, LOT devices and support applications. So initially all this data is stored in a traditional data lake. At first everything looks fine because data lakes can store any type of data at a low cost. But as the business grows, problem starts appearing. Multiple teams write data simultaneously, creating duplicate records and inconsistent files. So, updates and deletes become difficult because the data lake only stores files. So, if a job fails halfway through writing data, some files are updated while others are not. So, leading to inconsistent reports. It will lead to business users begins losing confidence in the data. Then the company needs a platform that maintains low cost storage while providing reliability, consistency, and enterprise grade data management. So, this is exactly why Delta Lake was introduced. So, Delta Lake enhances a traditional data lake by adding ACID transactions, versioning, schema enforcement, and better support for analytics and machine learning. Now, let's understand how Delta Lake fits into a modern enterprise architecture. So, everything begins with operational systems such as ERP applications, CRM systems, websites, mobile apps, APIs, and LOT devices. These systems continuously generate structured and unstructured data. So here Azure Data Factory, Apache Kafka or Event Hubs ingest this data into the Delta Lake platform. So the first layer is the bronze layer. Here raw data is stored exactly as it arrives. Then no business transformations happen at this stage. The next step is the silver layer. Here we can cleanse data, remove duplicates, standardize formats, validate quality and apply business rules. Finally, business ready data sets are stored in the gold layer. So these data sets are optimized for reporting, dashboards, machine learning and executive analytics. Governance tools such as Unity Catalog or Microsoft Purview manage permissions, lineage and auditing, also metadata. So Power BI dashboards, AI models and business users consume trusted gold layer data. Then this layered architecture makes Delta Lake scalable, secure and enterprise ready. Now let's follow one customer order through the complete Delta Lake pipeline. So a customer places an order through the company's mobile application. Then Azure Data Factory or Kafka captures the transaction and sends it to the bronze layer. Then bronze stores the raw event exactly as received, preserving the original data. Then next, the ETL process validates mandatory fields, removes duplicates, standardizes formats, and enriches the data. Then the clean data is stored in the silver layer. After that, business calculations then begin. Then sales totals, customer metrics, product performance, and business KPIs are calculated. So these aggregated data sets are stored in the gold layer. Then Power BI dashboards, executives, analysts, and machine learning models now consume this trusted data. One major advantage is that Delta Lake supports merge, update, delete, and upset. So operations are directly. So if a correction is required, we don't rewrite the entire data set. We simply update the affected records using ACID transactions. So this significantly improves performance while maintaining consistency. Now this section reflects real production experience. So building data lake is not enough, implementing it correctly is equally important. Always follow the Mendelian architecture using bronze, silver and gold layers. Store data in packet or format with delta transaction logs. So choose partition columns carefully, and over partition creates too many small files and reduces performance. Use optimize regularly to compact small files. Then apply geoordering on frequently filtered columns such as customer ID, order date, or region. Then this improves query performance significantly. Also, run vacuum carefully to remove obsolete files after the retention period. Then never run vacuum immediately because it may impact time travel functionality. Enable auto optimize and auto compaction whenever possible. Use schema evaluation only for controlled business changes. Then maintain governance using Unity catalog. Then implement monitoring alerts, audit logs, lineage tracking, encryption, and role based access control. Then the most production mistakes included here, that means common production mistakes. So ignoring small files problems, then not running optimizing techniques, use poor partition strategies, then running vacuum with an unsafe retention period, ignoring data quality checks, and the last one is not implementing proper governance. So avoiding these mistakes results in a stable, scalable and high performing Delta Lake platform. Then now we are in interview section. So the interviewer can ask like, what is Delta Lake and how is it different from a traditional data lake? So this is how we have to answer. Delta Lake is an open storage framework built on top of a traditional data lake. So it stores data in open formats like Parquet while maintaining a transaction log that enables ACID transactions. Unlike a traditional data lake, Delta Lake supports reliable merge, update, delete and upset operations. It provides time travel, allowance previous versions of data to be queried or restored. Then schema enforcement prevents invalid data from entering the platform, while schema evaluation safely supports controlled schema changes. Then Delta Lake supports both batch and streaming workloads on the same data, reducing duplication and simplifying architecture. In enterprise projects, I recommend Delta Lake whenever the organization requires reliable analytics, machine learning, streaming, governance, and scalable cloud based storage. So it combines the flexibility of data lake with the reliability traditionally associated with a data warehouse. So few practical tips from my production experience. So don't use Delta Lake just because it's popular. Choose it when you need reliable updates, governance and scalable analytics. Then keep bronze immutable and perform transformations only in silver and gold. Then regularly run, optimize and monitor small files. Be careful with vacuum because it affects time travel. Then implement governance and monitoring from the beginning, not after production issues occur. Then this brings us to end of today's episode on Delta Lake architecture. So the biggest takeaway point is Delta Lake transformation a traditional data lake into a reliable, ACID compliant, high performance, enterprise ready platform by adding transaction management, schema enforcement, versioning, and unified support for batch and streaming workloads. So, if you found this video helpful, please like, share, and subscribe to the channel. Don't forget to press the notification bell so you never miss the next episode in our Enterprise Data Engineer interview series. Thanks for watching, and I will see you in the next episode with Enterprise Data Quality Framework. Thank you.